Section 7, Unit 3, Surface Grinding Operations. Introduction. Surface grinders produce flat surfaces by grinding with the face of the grinding wheel. Machines are available with a vertical spindle or a horizontal spindle. Table motion may be reciprocating or rotary. Horizontal spindle/reciprocating table machines are very common. General surface grinder safety. See caution list in next text. Mounting the grinding wheel, 1 of 3. Remove spindle nuts to release old wheel, left-hand thread. Perform ring test on a new wheel. Install the wheel using blotters and clean burr-free washer. Install nuts and tighten by hand, left-handed thread. Jog spindle and run to test. Loosening the spindle nut on most grinders requires 2 wrenches. And wheels should always be ring tested before they are installed. Ring testing the wheel for soundness. So if it rings, it's good. If it's a thud, it's bad. It's got a crack in it. Magnetic work holding devices. Common magnetic devices are permanent magnetic chuck, electromagnetic chuck, magnetic parallels, magnetic V-blocks, magnetic angle plate, and magnetic sign chuck. On picture A, it shows a permanent magnet. Picture B, an electromagnetic chuck. And the control for the electromagnetic or magnet offers the ability to verify the magnetic force exerted on a workpiece, which can limit distortion on thin workpieces, which is on C. The gold lines on the chuck represents the line of magnetism. The workpiece should span of 3 or more of these lines to be safely secured. Notice the back rail on this chuck. It is used to help align the workpiece on the chuck. Blocking consists of placing pieces of ferromagnetic metal around the workpiece. This is done to help hold the workpiece secured during the grinding operation. When using this method, it is important to make sure the blocking material is shorter than the actual workpiece. Magnetic parallels extend the magnetic field of the magnetic chuck. And there's magnetic V-blocks, which actually that's magnetic 1, 2, 3 blocks, but there's magnetic V-blocks. Magnetic sign chucks can be used to hold a workpiece at a present angle. The angle is set by using a gauge block build as with a sign bar. And a workpiece is often passed over a demagnetizer after grinding. Non-magnetic angle plates, V-blocks, and collet blocks. Standard angle plates and V-blocks for milling can be used for grinding. Grinding vices differ from milling vices, typically higher precision. Grinding vices are very accurately ground and can be used quickly and accurately secure workpieces. Wheel dressing and truing. Dressing and true wheel before use. Dressing sharpens. Truing eliminates runout. Truing makes the wheel face run true to its axis, and dressing sharpens the wheel. Dressing and aluminum oxide and silicon carbide wheels. Aluminum oxide and silicon carbide wheels are dressed with diamond dressing tools. Single point diamond dresser is on the left, and multi-point cluster dresser is on the right. Preferred location for diamond dresser on the left edge of the chuck. The proper dresser position is important safety consideration. The diamond should be offset to the left of the wheel center line. If the diamond is angled in its holder, the angle should be placed as shown. So it shows you the diamond on the left side of the wheel. Of course, there's the holder, the magnetic chuck, and the wheel guard. So make sure it's on the left side. The dresser is being positioned near the edge of the wheel. The dresser is fed across the face of the wheel to perform the dressing operation. Feeding the dresser slowly will result in the wheel having a slightly more closed structure, while feeding faster will produce a slightly more open structure. Diamond Dressing diamond and CBN wheels. Diamond and CBN super abrasive wheels. 1. True first wheel brake truing device. And 2. Dress with dressing stick to remove some bonding material. And then there's an illustration of brake truing. Grinding parallel surfaces. Most basic common operation. Often best to grind largest surface first. Clean chuck and ensure workpiece is secure before grinding, and grind magnetic chuck periodically to ensure that it is flat. The grinding wheel should travel all the way off the workpiece at the end of each longitudinal pass. The table should be cross-fed far enough so that the wheel travels off the front and the rear of the part. When touching off, the grinding wheel is positioned so that only about 1/8 of its width is over the work. The layout fluid can make it easier to see when the wheel touches, since the dark blue provides a good visual contrast to the workpiece. The arrows show the direction of feed as a surface is ground. So, of course, your longitudinal feed and your cross feed. So if we started here, it'd come over, go up, go over, go up, back and forth until you're all the way past the part. Grinding perpendicular surfaces. Set work perpendicular to the magnetic chuck using an angle plate or grinding vise. Angle plates are often used to grind a workpiece square. If set up properly, 2 perpendicular surfaces of the workpiece can be ground without repositioning and work of the angle plate. If the part is positioned so that the left side extends past the angle plate, while the side facing up is ground. Without repositioning the work, the angle plate is turned on its side for the grinding the adjacent side. Clamps must be repositioned for clearance with the grinding wheel. So you see over here, it's hung off the left side. So we do the top, they reposition the clamps on the front, and they flip the angle plate to the side, and then they grind the adjacent side. A precision grinding vise can be used to place an angle plate when grinding perpendicular surfaces. Same way. You can see here it's hung over the left side, it grinds the top, you flip it on the side, and you grind the side. Grinding angles. Angles may be ground by holding work with a magnetic V-block, a sine bar, an angle plate, and a magnetic sine chuck. There's a magnetic V-block, and they are helpful when grinding 45-degree angles. Using a sine bar, a gauge block shows to position the workpiece on the angle plate. The 1, 2, 3 block is being used to raise the workpiece above the top of the edge of the angle plate. Magnetic sine plates can also be used with gauge blocks to set up angles. This method is very accurate. Side grinding. Side of the wheel is used to grind the work. Periphery of the wheel and side of the wheel are often used at the same time to grind the vertical surface and adjacent surface perpendicular to each other. Dress side of the wheel with an undercut before grinding to reduce heat. The dresser should be positioned on the end and aligned with the center line of the wheel for side dressing. The dresser being used to dress the side of the wheel. Dressing a small undercut into the wheel can help reduce the amount of surface-to-surface contact between the workpiece and the wheel. So it's showing that this is the undercut area, and this is the narrow area raised above the undercut area. Dressing a small undercut can also be performed by hand using a dressing stick. Performing side grinding. Mount work parallel to table travel. A dial indicator being used to align the workpiece with the longitudinal travel on this one. And this one shows positioning the wheel near the surface to be ground. There's grinding horizontal and vertical surfaces. Grinding cylindrical work. Cylindrical features may be ground using a cylindrical grinder, a centerless grinder, and an indexing fixture. Cylindrical features may be ground by indexing a fixture. Indexing fixtures may also be used to grind radii and angles. A collet type fixture can be used to produce cylindrical or angular surfaces. Cylindrical features may be ground using a cylindrical grinder, a centerless grinder, or an indexing fixture. Indexing fixtures may also be used to grind radii and angles. A is the center of the workpiece should be in line with the center of the wheel when using a spin fixture. And B, lower the wheel head while rotating the fixture hand wheel to grind the cylindrical surface. And there's a picture of that. Grinding problems. Common grinding problems: burning of work surface, scratches on work surface, and waviness, chatter on work surface. So here's your workpiece surface. Areas missing cobalt due to leaching, and then cobalt binder, and then carbide particles. Carbide particles that are adequately surrounded by cobalt binder material on the left compared to the carbide that has lost the carbide binder due to leaching on the right. Burn marks appear as dark streaks in the surface of the workpiece. You can see them around here. And the wavy surface may indicate a loose or out of round grinding wheel.